So this will be a little bit of old stuff and a little bit of new stuff. Essentially what I'm going to do is just tell a whole bunch of more or less haphazard stories, and then we'll drag a theme out of it. Yeah, that's the plan. So we'll start with toads, because to some extent that's where I started. So many of you will know, Vic Sept, just walked in, this is the boring Vic Sept, sorry. Cane toads, right? This critter here, basically a large frog-shaped thing with their toes. We don't have any other toads in Australia. They were introduced by the sugar industry to Gordon Vale in 1935, and there was, in 1936, there was an immediate ban put on releasing them any further. A guy by the name of Walter Froggatt, would you believe, who was actually an entomologist, sounded the warning. He was like, we can't let these things go. There will be no limit to their westward spread, and they're going to become a bigger pest than the cane beetles ever were. Basically what happened was the sugar industry got outraged. They talked to the Queensland Premier, who talked to the Prime Minister, and there was a letter from the Prime Minister's office saying, keep letting those toads go. So Walter's advice was ignored, and the Sugar Research Bureau then released toads from Gordon Vale down to Bundaberg and Mackay, all the sugar growing districts in Queensland, and the rest is history, right? So that's a bunch of points about where toads were in 2006, and I've just, because I can never keep up with this, the invasion front's now pretty much all the way through the Kimberley, so there's not much left of the Kimberley that they haven't occupied. And these records are a combination of new records, but also these historical records that Sabbath and co put together from Griffith University back in the 1980s. This was a really cool bit of work. They just wrote to all of the post offices and schools around Queensland, and they asked when toads arrived. So they were able to reconstruct the history of the toad invasion just by writing lots of letters. Actually, it wasn't these guys, it was Jeanette Kovacevic that led that work. So there's all these historical records of toads, and one of the really cool things you can do with the historical records is you can work out how fast the toad invasion was spread as it moved across Australia. So you get these historical records, and what you discover is that the toad invasion used to spread at about 10 kilometres a year, and then as it spread across northern Australia, it just got faster and faster and faster until it was doing about 50 kilometres a year. So I just kind of stumbled on that pattern one day, and it's a big one, right? It's a big pattern. It made me wonder what was going on. If I'd been more versed in, the theory of invasion biology, I would have probably come to a different answer, but because I had a background in evolutionary biology, I thought of an evolutionary explanation, which turns out to be what's happening. So if you this looks like a circle, but it's actually a population of toads, right? Yeah. There's a population of toads there, and they're all tightly held in a fence. And what we're going to do is we're going to lift the fence, and when you do that, they all move, and you get this new kind of range, if you like. So all the toads move. The thing is, not all of the individuals move the same distance, right? So some individuals don't move very far, most individuals move some kind of average distance, and then there's a few individuals that move a very long way, right? That's just natural variation. If you think about the individuals that make up this new range edge, they have to be the individuals in the population that move the furthest, right? So it's the fastest moving individuals that will be on this range edge. There's no other way they could be there, right? So this process of moving through space gets all of the fastest moving individuals and it puts them in the same place at the same time. And the mating game being what it is, of course, you end up mating with someone nearby. And so you've basically got all the most athletic individuals, you have them mating with each other, and the offspring are going to have a rate of movement that's higher than the average of the population from which they were originally born. And so you can see this process will happen every single generation as the invasion progresses, right? So this is really quite strong selection for increased dispersal ability, at least in theory. So at some point when I was younger and more energetic, I drove across northern Australia and picked up toads from various places. So moving across the toad invasion history, from where they were introduced to all the way across to Timber Creek. where they were in 2000 sometime, 2006. And then I brought them all back to Rick's research lab at Middle Point, and I radio tracked them all, and lo and behold, the ones from the invasion front moved a lot further than the ones from that have been collected from the core of the range, right? So, and because I was really stupid and energetic, I bred them all in captivity and repeated the experiment with offspring, and pretty much the same story as well, right? So there's this genetic shift towards increased dispersal on the range front, and it's happening purely because of the process of invasion. And it's happening fast, right? So you've got an invasion moving at 10 kilometres a year here, now doing 50 kilometres a year, so it's caused the invasion to accelerate fivefold. So that's one of my random stories. Toads are doing interesting things. But the reason I got interested in toads in the first place, so that was just like an accident really. I was interested in toads because I was interested in snakes, and I grew up in northern New South Wales where I had plenty of chance to observe, so I was essentially right on the range front of toads when I grew up, and I was right into red-bellied black snakes, and so I had plenty of chance to observe that red-bellied black snakes were not in places where toads were, but they were in places where toads were, and obvious implication being that toads have pretty much wiped out the red-bellied black snakes. So my PhD, as Connor mentioned, was all about thinking about the impact that toads might have on snakes. When I finished my PhD, I was lucky enough to go and work up in the Northern Territory, that place I mentioned before, up at Middle Point for Rick Shine. And one of the things I really wanted to do was work out what would happen to the snakes when the toads arrived at this long-term research station that we could be running. And so I was able to get up there a few years before the toads arrived, and that was the only reason I was paying any attention to how fast I'm moving, because I wanted to know when they'd get there so I could do my snake experiments, right? So anyway, so I started doing work on death adders and toads. Now, I know this is the Froggy group, so I'm a little bit sad to report this experiment, but there's all these really cool frogs on the floodplains up north, and death adders like to eat them. And this new kind of frog is about to turn up, so it struck me as being pretty important to know what death adders do when they eat different frogs, right? And these frogs have different defences. I wonder if death adders might treat them differently. So you'll see what's about to happen here. This is on the right is a young toad in a takeaway container, because it's the kind of high-tech science we do. Right, it's pretty clear what would happen if the takeaway container wasn't there, right? So this is work done mostly by a fellow called Matthias Hagman, did this work. But what he found out was that if you look at the, so these are those frogs again, the rocket frog, Victoriana suda, Lindonassus convexiasculus, I think they're called marble frogs, I can't remember, Latoria dahlia, and toads over here. And if you look at the percentage of times each of these prey species elicited a lure from like a tail wiggle from death adders, you can see that death adders pretty much didn't wiggle when the suda around or convexiasculus, but they did quite a lot of wiggling for Latoria dahlia and, as it turns out, toads. So that's a bit of a maladaptation when toads are on their way. And then you look at the responses of the frogs to the lure, right? So these native frogs, of course, have grown up with death adders. They've got long evolutionary experience with death adders, so you might expect that they'd be a bit keyed into not approaching a death adder lure, and it turns out they're actually pretty good at not approaching death adder lures. Cane toads, however, never seen a death adder before in their lives, well, in evolutionary history at least, and they're actually pretty hopeless, and so they just come by, oh, food. So this looks like, you know, a train crash about to happen, right? You've got something about toads gets the death adder excited, and that lure gets the toad pretty excited. So that's a graph of a train wreck about to happen. One of the interesting things about these, or some of the interesting things about these frogs, right? Latoria nasuta, as far as we know, is fairly non-toxic. Its main defence mechanism is that it has this ridiculously long legs and it springs away, right? We call rocket frogs for good reason. One of the fun ways to catch them is with a butterfly net. Anyway, so we can think of those as tasty delicious because they're not toxic in any way. They're basically delicious food if you're a snake. Then we've got Limnodynastes convexiosculus. Now what these guys do is when they get upset, they secrete a really gluey, a nasty glue basically that takes about 10 minutes to set, but it's very sticky. And then there's these guys, Latoria dalii, and it turns out that these are horrifically toxic. And there's something, no one quite understands how it works, but they have a toxin that, well, people understand how the toxin works, but it seems to appear very quickly in the skin when it's needed. But it's essentially a neurotoxin, right? In the way it works. Apologies to anyone who's a biochemist who will just shake their head with that explanation, but you don't want to eat a Latoria dalii. It would be very bad. So some work by Thomas Madsen in the 80s. He had actually done this strange experiment where he force-fed these various frogs to death adders because he was finding them. He was this is kind of from Thomas. Anyway, he was finding all of these species of frogs in the snakes' stomachs, and so. But he knew that this one was toxic, so he was trying to work out what was going on, and he force-fed dead versions of these to death adders, which would have been a fairly unpleasant event for everybody, and discovered that if you force-feed one of these to one of these, the death adder will die. Right, so Latoria dalii are very toxic. And yet he keeps finding them in the frog's stomach, so what's going on? Well, it turns out that death adders are very sophisticated creatures, and they have a completely different response to each of these frogs. So there's a bit more nuance in it, but to summarise, the tasty deliciouses, Latoria nasuta, they basically just grab them and eat them. They often don't even envenomate them, so it's a pretty sad use for a frog lover, so I'm sorry to impart that use, but that's essentially just grab them and eat them. Limb convexiosculus, however, they bite them and envenomate them, and then they lift their mouth up, and they basically just sit them in their mouth and wait. And the frog dies quite quickly because it's just been envenomated by a death adder. And about 10 minutes later, they just eat it. And it turns out that the glue dries in about 10 minutes, right? So they basically just bite it, envenomate it, and wait. Glue dries, and then they can eat it. So it's a pretty good trick. The dalii, so this is this horrifically toxic thing. Every time, pretty much every time, they bite them and they drop them immediately, and then they sit there like that, with their mouth open. And they just sit there. And they'll sit there for about 40 minutes. It's about 40 minutes every time. And then they'll close their mouth and they'll start tongue flicking and they'll go and find the frog and they'll typically eat it. Sometimes they'll taste it a little bit first and leave it for a bit, come back 10 minutes later. So there's something going on where the death adders can kill these frogs with their venom. And 40 minutes later or 50 minutes later or an hour later, the frog is not toxic. Don't ask me to explain why, but this is what the death adders are doing. Right? So here's this snake with a brain the size of something really small. It's doing these very different behaviours for these different frogs. This is essentially the same story I told you. It's just different. You can just see there's just like no overlap in the amount of time that they're waiting. They're just doing very different things for each of these frog species. We're going backwards. So this made me wonder how they might respond to toads, right? There's a bit of a ticklish operation, but essentially it boils down. This is the summary of how it works. If you give a death adder one of these frogs that it knows about and that it's evolved with for some thousands of years on this floodplain, there's these kind of three different ways, three different sets of behaviours that they use. And about 74% of the time, they will use the behaviour that matches each of the frog species, right? So obviously these ones, they'll wait 10 minutes or they'll wait 40 minutes. Every now and then they make a mistake. So they one of these, I think it's one of these or something, right? So they make a few mistakes, but most of the time they get it right. And every now and then, with a Dalii, they do something very different, which is they kill the Dalii, they go over, they taste it, they gape for a bit longer, they taste it again, they gape for a bit longer, they taste it again, and after a while they're like, you know what, I'm just not going to eat that. And that would be a pretty useful strategy for toads, right? So you ask them, you find out what they do when you offer them a toad, and about 46% of the time they do that. They kill the toad, they drop it, they gape, wait, they come over, taste it, they never eat it. But the other 54% of the time, they misclassify as one of these three things, and that's a bad outcome. Right? So there's all this complexity going on in terms of prey handling that we just didn't know about. But of course, this variation is variation that probably has, everything has a bit of genetic variance. This is the fact that there's variation there, and about 46% of them, first time you ask them, won't actually eat the toad, right? Because when the toads arrive, we might expect that some of the death adders might survive. And so we followed that up, or I followed that up with radio tracking death adders. So the toads were coming the whole time all this work was being done, and so I was in a position to catch a bunch of death adders, put radio transmitters in them, put them back into the field, start radio tracking them, and then the toads arrive. And the expected thing happens, right? None of these are set up shots. This is you're radio tracking and you would find a dead adder next to a toad, sometimes next to an absolutely ginormous toad. This death adder actually recovered. It looks mostly dead, but it recovered. But not all of them died, right? Many of them lived long, happy lives. And so, this is, I've forgotten the years now, you can't read them. Maybe that's 2005, anyway, something like that. This is the numbers of toads going up each year, and this is the death adder population each year. Right, so massive impact. So something like 95% of the death adders were gone. So these weren't animals I was radio tracking, this was just our counts on the road every night of death adders, and the population was just plummeting. But the radio tracking work showed very clearly that it's a survival rate. These ones that tended not to interact with the toad in the lab, treated toads as toads in the lab, they survived really well. The other trait that predicted survival was relative head size. So the ones with relatively small heads, so less able to poison themselves in a toad, also did a bit better. Interestingly, body size didn't make much difference, and nor did their resistance to the toxin. So there's a bit of variation in toxin resistance in the death adders, but there's this much variation, and what they need is this. So as a consequence, even though there's variation in toxin resistance, it doesn't affect survival, basically, if you eat a toad. It doesn't matter if you're the most resistant death adder population, death adder in the population, you're going to die. So toxin resistance, even though that's one you kind of think of with the under selection, it's not actually under selection. So it's not going to really evolve very much. But this prey preference, very, very much under selection. So I'm happy to report that sorry?
Can you please speak up when they're yelling?
Okay.
Yeah.
I'm very happy to report that last I was talking to Greg Brown, who is Rick's long-term postdoc in the Northern Territory, and Greg would know him very well. He was saying that he's starting to see more death adders. So 10 years later, whatever it is, maybe it's a bit more than 10 years, I've lost track of time, the death adders are starting to come back, and I will bet that none of them eat toads. This is rapid evolution happening before their eyes. So, That's my second story. Okay, quolls. So, as toads spread across Northern Territory, they cause massive population declines in all sorts of things, including cute mammals. So, there's the quoll. You know, it's a carnivorous marsupial thing, and toads come along, and they're going to be bad news, right? So, a couple of things to report here. The Northern Territory government put a bunch of quolls onto a remote island off Arnhem Land called, this is a Stella Island here. That's Cabasso, the other one over there. And put them on there to keep them safe from the toads. So these are islands that are far enough away from the mainland that we don't expect toads to get there. There was no quolls on these islands. They came and introduced a bunch of quolls, and the population went absolutely nuts. Now, at some point in all of this, a fellow by the name of John Webb, who's at UTS, he came up with this idea that you could train quolls to avoid toads, right? And the basic idea is, I'm sure no one here has done it, but I know I've heard this is true, I'm not sure it's right myself, but apparently if you drink too much rum or whiskey and it makes you really sick, the smell of it thereafter makes you feel sick for quite some time, right? Just I heard from a friend. So it's the same idea, right? So you give them something that tastes like toad, smells like toad, but has a nauseating chemical in it, not rum, something else that they can't taste. Makes them feel really sick, and very rapidly you can get them to avoid eating toads. And it works quite well, right? You can make up these ghastly baits and it's a toad, and then you can put a toad into a cage where they can't get to it, and you can score their behaviour. And the ones that have been trained are much less likely to attack or claw at a toad. They just sort of keep it away from it. So we had the idea at some point that we could go to a Stella Island. So there's now thousands of toads on these islands, and we could capture some toads. So this is a project done with John O'Webb. We captured some quolls, so toads, and we can train them to avoid toads, and then we can bring them back to Kakadu National Park. Right? It was a really exciting idea. So we did that, trained a bunch of quolls, and we had to have a small control population. So this is the survival of the control population. So in a matter of days, the quolls that hadn't been trained had killed themselves on the toad, right? That's how fast it happens. And if we look at toad mortality, so these are the ones that were trained, a few animals were silly, but mostly they didn't eat toads, right? So it's potentially a success story, but I'm misleading you a little, because what actually happened was this. These animals did actually die, but it wasn't from toads, it was from dingoes. So we kind of solved one problem, a little bit, and then the dingoes came in. A student of mine, Chris Jolly, was leading this work, so he was radio tracking quolls over Kakadu and just kept finding dingoes, which was very distressing for him. And this made him wonder, right? So these quolls have been out there on the island for 13 years. They've been predators out there, and so it made him wonder if maybe they've lost their ability to recognise predators. So he did some trials in captivity where he offered them different scents. And so these are the animals from the island, and these are some quolls from Queensland, from the mainland. And you can see there's a pretty clear difference in terms of their response to cat and dingo scent, right? So these island quolls that we got off the Stella Island, they pretty much, there was no response. Whereas the mainland ones were very, very interested in dingo and cat scent. And just like my ludicrous experiment with toads, we bred them all in captivity and we asked them the same question again. So these are captive born animals. they've never seen a cat or a dingo before. If they're captive born from the island, we get no interest whatsoever. If they're captive born from the mainland, we get a pretty clear interest in cats and dingoes. So again, it starts to look a bit like this might be a genetic shift, right? So they were in Kakadu, living with dingoes. We put them on the island for 13 years, we bring them back, and they don't recognise a dingo. Unbelievable. But this made us worry a bit, because this is like a kind of key plank of a lot of our conservation of threatened mammals in Australia is we put them into conservation havens where they're free of predators, right? So wildly successful strategy, we're keeping populations of bilbies and oilies and numbats from going extinct, right? It's really important work. But if the same thing that's happening with the quolls is happening in these populations, then we may never be able to release them back out of these enclosures again, right? So this is an interesting problem that's being worked on at the moment, right? There's this distinct possibility that a lot of these conservation havens are actually selecting quite quickly for the loss of anti-predator traits. So that was a few stories. The theme that I'm trying to get at is that traits, so it's not just population sizes of things, but it's the traits that individuals carry. They mediate the impact, or they mediate the conservation problem in all sorts of interesting ways. And traits evolve, right? So this is the basic theme that I'm trying to get at. So if we just take this happy picture here, what I mean when I say traits mediate the impact is that from the cat's perspective, whether it gets the bird or not will depend upon the cat's size, its prey preference, how good it is at hiding, the kind of habitats that it chooses to hunt in, when it's active, how good it is at stalking, how specialised it is, how generalist or specialist it is. And from the bird's perspective, all of these kind of traits matter, right? They all matter, and most of these traits will probably evolve under selection, right? So I think that the point I'm trying to get at with all of these stories is that there's all sorts of interesting conservation problems happening out there that we often don't think about them as problems to do with evolution, or problems we don't often even think about the traits involved. Right? So a few years ago, made me wonder what we can do to utilise traits for conservation. The reason I was thinking this was, this is typically how we spend our conservation money, right? This is time, this is the amount of money we spend. So we spend money, I don't know, controlling cats. So we bait for cats, and then next year we bait for cats, and next year we bait for cats. Or we set up conservation haven and we fix the fence, Right, so we spend money, like once we commit to an action, we often just spend the money like that forever, right? So the amount of money, total amount of money we spend just grows with the size of that rectangle. Wouldn't it be good if we could come up with strategies where we did this? And I feel like there might be avenues for harnessing evolution and rapid trait change where we could get this to happen. In which case our conservation dollar is this instead of that. So the last part of the talk I'll just try to flesh it out a little bit more using some of these examples. So back to quolls again. This is the historical distribution of quolls, this light grey. This dark grey is the current distribution as of, I don't know, 1994 or something. They're pretty much gone for most of there now. This is the toads distribution. This is a kind of rough idea about where the toads might get to, ultimately, maybe. So that's the kind of geographic setup. The PhD student of mine, Ella Kelly from UNI Melbourne as well, she was really interested in the quoll story. So she went and got toads, quolls from Queensland, and we had the quolls from Stella Island. And she asked them what kind of what their reactions were to a control prey item, which was a mouse or a toad. And really, the only thing to look at here is these white bits, right? So these animals from Estelle Island, they were very happy to attack a mouse. They were very happy to attack a toad, more or less. If you went to the animals from Queensland, however, these are animals that we collected from Queensland in Maroubra. They're desperately excited about attacking a mouse and utterly disinterested in attacking the toads. So they know, right? Maybe this is learning, right? So we do the old breed them all in captivity again. We do there's the slide, so we bring them in captivity. It's a different graph because there's a whole bunch of strange logistical things happen. But these are offspring of the Estelle Island animals. These are offspring of the Queensland animals, and these are hybrids between those two populations. So we crossbred animals from here and here. And we asked them whether they would eat a toad leg. Like, it's a back leg of a toad. It's actually not toxic enough to kill the quolls, so that's good. And about 60% of the offspring of the toad-naive animals were happy to eat a toad leg, as opposed to about 30% of the offspring from the Queensland animals. Right? So again, it's starting to look like a genetic effect. Interestingly, the hybrids come out bang next to the Queensland animals. Not in the middle. They're showing basically the same pattern as the Queensland ones. Well, that is a hint that the genetic basis of this is a dominance effect, right? So when you do this, when you cross them, you're going to get the toad smart phenotype instead of some intermediate. But the other interesting thing about this is it suggests there's about, I think it was like 36% of the toad-naive animals, so these animals from Northern Territory who have never seen a toad before, about 36% of them didn't want to eat a toad. So there's some natural variation out there. Some of the quolls don't like their Brussels sprouts, right? It's like they're just not interested in toads for whatever reason. And that's the kind of thing that natural selection can act on. So we did some modelling of this, and this is kind of what this is an example run, right? You have a population ticking along, toads arrive and book goes extinct. Alternatively, you have a population of quolls going along, toads arrive, it almost goes extinct. Just before it goes extinct, you introduce some animals from Queensland. That's this little bump here. We'll just move 20 toad smart animals from Queensland. And instead of going extinct, the population mounts a very rapid evolutionary response. And we see this is like a classic pattern called evolutionary rescue. So in theory, that's what should happen. Right? So if we nailed the timing, toads are going, toads arrive, and before our population goes extinct, just before, we introduce some Queenslanders, the Maroons, genes of the Maroons, can rescue the population, right? So this is a modelled result, but it's kind of what should happen. Conservation people were traditionally quite concerned about outbreeding depression. They're like, you're crossing animals from the other different distant side of their range. So we set up an experiment to test that. We went to an island off Darwin, worked with Canberra Rangers, who were just freaking brilliant, and we introduced a hybrid population. Quolls, right? So some Northern Territory animals, some hybrid animals, those hybrid animals that are in that graph actually, and 10 Queensland males, right? So we introduced this population and we trained them all to avoid toads. Right? So we used that training method. And so what we were very much hoping was that all of these animals would live to reproduce. So there's toads on this island, right? I should mention there's toads on this island. What we were hoping was that these animals would live to reproduce, so they've all been trained to avoid toads. We would get a hybrid population, we'd see rapid selection towards Queensland genome. That's what we were hoping. Things don't always go to plan. So we went back and we did this freaking massive effort. It doesn't look like it. Each of those is a trap. You have to carry them from the camp through trackless bush over hills and through scratchy vines and various other things and put them out. And we census our quoll population. So we let all of our quolls go here. And then next year we came back and we did this massive tracking effort with the help of Canberra Rangers. We couldn't have done it without them. And this is the sad story, right? The population went from, this is the number of animals we introduced. Next year we had like that many animals, and the year after that we had almost no animals, and all the animals we caught were female. So we're pretty sure that the population has actually gone extinct. So that's very frustrating. It wasn't entirely due to toads. A cyclone hit here. What happened first? I can't remember. Right in the middle of the breeding season, this got burned. It hadn't burned for 30 years, which is why we picked this spot. It hadn't burned for 30 years. It was like beautiful all-over logs, everything was amazing. And right in the middle of the breeding season, when females were deading with babies, a massive fire and trees burned everything. So that probably caused some mortality. There was toads there. We expected toads to cause some mortality. But here's the killer, the most frustrating thing of all. We worked out after the fact that the training, so this training method, it only lasts for about 2 or 3 months. So just like you can get over your rum, smell, whatever it is you drink, right? Quolls get over it too, because quolls have lived for a few years, they get over it faster than humans do. And so even though we train these animals, quite likely a lot of the animals that we trained forgot that lesson and actually ate a toad. So that was something we didn't know at the time when we set the experiment up. But we were able to, with the 6 samples of animals that we got from the island, that had been born on the island, we were able to show that we had most of the hybrid classes that you would expect to have emerged, right? So there's no indication of any outbreeding impression here. All of these hybrid classes appear to be viable. So again, in theory, it should be possible to do this. And bear in mind that the way we set this experiment up, we introduced the population onto a place where there's toads. What we're proposing instead is you have a perfectly happy, healthy population of quolls, you introduce some genes to those, and then the toads are up. It's a very different scenario from what we did on the island. And Ella did some just like insane amounts of modelling to work out when you would need to introduce the animals and how many you need to introduce and so forth. You know, this is the feasible, it's feasible. So that's that idea. This is this idea of targeted gene flow, that we might be able to bring the traits that we can potentially bring traits from conservation benefit into populations simply by looking for the geographic variation of the traits of interest and putting them where they need to be at the right time. Still yet to be demonstrated. I wish I had a great story that it all worked, but it's still good in theory. It just hasn't been done. So here's another crazy idea about targeted gene flow. We have this really exciting opportunity coming up in the next few years. So these dots are artificial water plants. Pastoralists putting onto the face of Australia to graze cattle. Is it right? This is the toad's distribution roughly. This is an interesting spot. So this was first noticed by Mike Letnick and co in his paper Florence set out. It's kind of obvious once someone points it out. Right? Here's the Great Sandy Desert. Right? It's very hot, very dry. You're not going to find many frogs there. Although there's some nice notables kicking around here. Anyway, beside the point. This is hot and dry. Toads aren't going to live in the Great Sandy Desert. And it's no good for cattle either, really, so there's no pastoral water points. But along this little strip here, there's just enough moisture for pastoralists to make a living, and they can put water points in. Now it turns out that what Mike and Dan Florence and co pointed out was, well, this is like a corridor for cave toads, right? They're going to get to here and then they're just going to once they get into the Pilbara, it's like game on again, right? There's like water and it's great toad habitat. I'm like, wouldn't it be nice if we could stop them there? Just keep them out of Pilbara, keep them out of 270,000 square kilometres of country. So we did some modelling of this idea, and you know, sure enough, it works, right? If you don't do anything, the toads will just spread down that corridor. And once they get to there, they've got the whole Pilbara. These simulations are still running, but nothing's happening, right? So the toads just, if you take out enough water bodies along this stretch, the toad invasion stops, right? So it's within our power to stop toad invasion. All it requires is for us to manage artificial water points at a few key places between Broome and Port Hedland in a way that the toads, so wet season comes along, the toads disperse all they like, they come out into this area, fine, but as soon as the dry season comes, they're going to need to find water because they're not nomadans, they're not very good at burrowing, they've got no adaptations really for dealing with zero conditions. And so they just perish, right? And there's now quite a few studies showing that that is actually what happens, right? If you exclude toads from water in this part of the world, they die very, very quickly. So, and it turns out to not be very expensive, right? You can do this. So this is within our power to make this happen. I very much hope that we do make it happen because it keeps toads out of an area that's about the size of Victoria. So it should work, but these gaps, or this gap here needs to be about 70 kilometres wide. And it needs to be 70 kilometres wide because we're stopping those insane toads that are on the invasion front that are dispersing huge distances, right? They disperse huge distances. They like move 50 kilometres in wet season, it's just mad. There's no other amphibian on the face of the planet that does that. So these crazy toads are coming in here, and they're moving most of the way into that barrier. And that's why it has to be 70 kilometres wide. So that's where we got the truly evil idea that maybe we could set the barrier up and then we can just introduce some toads from Queensland onto the near side. Right? Here's the barrier, here comes these crazy toads. Let's just introduce some Queenslanders here. They don't move very far. And I'll just spread towards this one. And if we get this right, the highly invasive, the high, fast dispersing toads that are on the invasion front will never actually make it to the waterless barrier. And so we can potentially make this waterless barrier much more effective simply by moving the traits that we want to the place at a time where they can be most effective. So, you know, for the cost of an airplane flight and a very, very expensive public relations campaign, we could potentially make the barrier a lot more effective. And this is basically just a schematic that Ella put together. We have actually done more formal modelling, and you know, you can turn a barrier that's only 20% effective into one that's 70% effective or more, just by moving the low dispersal toads to that near side of the barrier to get the time right. So that's another one of those crazy ideas that comes from the idea of moving traits to where they can be useful. And that's it. My stories are over. Big thanks to everybody. If anyone wants to know anything more about genetic backbone, that's what that idea is called, and how it would work, they can talk to Greg Clark because he's an expert in these things. Otherwise, I'm done.